Okay, welcome back Physics 30s to our next lesson in Chapter 6. This is 6.4, and today we're going to be looking at line spectra. Okay, so in the last lesson we looked at the Bohr model and determined that the atom has distinct energy shells that can relate to certain photons that are emitted from that atom. So here we have those distinct electron shells or quantized energy levels. And if this electron gets excited or gains energy from another incoming electron, it will jump up into an excited state. And then it will soon lose that energy, jump back down, and lose its energy as a photon. And this is what gave us our bright line spectra. So we can see here, if I take an element and make it a rarefied gas, so make it so there's just a couple of those atoms in there, when I run the current through, we're going to get light. And when we spread that light out with a diffraction grating, we get these distinct bright lines. Now, if we did this with a solid, liquid, or even a non-rarefied gas, then the atoms are going to interact with each other and they're going to be able to shape different ways that we will get a continuous spectrum here and we'll get all the colors. And that doesn't give us too much information, but if we have that solid, liquid, or non-rarefied gas, and then that continuous spectrum passes through a cool gas, we get a spectrum that looks like this, or a dark line spectra. What's happening here is actually pretty similar to what was happening with the bright line. It's just that an electron can get excited not only by crashing with another electron, but also by getting hit with a photon. So imagine that all the colors of the rainbow are coming right here and interacting with this element. When a photon comes in that matches this energy difference between these two shells, that photon can excite that electron up to that energy level. That's going to absorb that photon or pull that out of the continuous spectrum. If something had less energy, not enough to get it up to that state, it would just pass on through and we would see it on the screen. But where we see those dark lines is where we see the ones that were absorbed by that specific energy level. Now, from that high energy state, the electron is going to jump back down and emit that photon again. So you may think that that emitted photon will now show up on the screen. But the atom can emit that photon in any direction. The chance that it goes directly on the screen is very low. So most of this light is just going to be spread out to other places, and we're still going to have those dark lines. So that's the three types of spectra that we can get. This bright line spectra is also called an emission spectra, because when it gets hit with electrons, the electrons are excited, fall back down, and emit these photons. And this dark line spectra, also called an absorption spectra, because those electrons will jump up to an excited state when they absorb the energy from those photons. And if we're talking about the same element, this is talking about the same energy states, so the lines should line up here, the dark lines and the bright lines. So let's just write down some conclusions. At the center of the atom is a small dense nucleus. Electrons exist around the nucleus in quantized shells, and we get an emission spectra. It's when atoms receive energy, electrons are excited, electrons fall back down to a ground state and emit a specific photon of E is equal to HF. Next was the continuous spectra. We don't focus on it quite as much, but it's when solids, liquids, or non-rarefied gases have it where the atoms can interact with each other. So when we heat it up, it's going to emit a range of wavelengths. Now I did put black body curve here. As you increase the temperature, you're going to increase the main frequency that's going to be emitted. We talked about that in 5.1. But the main focus being the emission spectra and the absorption spectra, which is where a continuous spectra passes into a relatively cool gas. The atoms are excited by the photons, matching their energy jump or change in energy states. They get excited, fall back down, and emit photons in all directions, so we get absorption, creating these dark lines. So I hope that has helped you to understand the different types of spectra. Thank you so much for watching, and I'll see you in the next video.